So good morning, student. In this video, I will be discussing Faraday's law of electrolysis. Faraday's law of electrolysis. So Faraday gave two laws of electrolysis. So first law. First law says that the amount of any substances deposited, or dissolved at a particular electrode is proportional to the quantity of electricity utilized. That is, W is directly proportional to Q. So W is equal to ZQ, where Z is called electrochemical equivalent. Z is called electrochemical equivalent of a substance. Electrochemical equivalent of a substance. And it is equal to, Z is equal to equivalent weight per unit Faraday. So Z is equal to E upon F. So we can write W equal to E upon F into Q. We know that charge is equal to current into time. So we can put this in equation. So W is equal to EIT upon F. That 1 Faraday is the charge carried by 1 mole of electron. So we can write weight of electrolyte deposited is equal to equivalent weight into current into time upon 96500. So this is Faraday's first law of electrolysis mathematical equation. Now let us solve few questions based on Faraday's law. So keep in mind, student, that 1 mole electron charge on 1 mole electron is equal to 6.022 into 10 to the power 23 into 1.6 into 10 to the power minus 90. If you calculate this, this will come like 96487. For simplicity, we take it like 96500 coulomb per mole. So this is the charge carried by 1 mole of electron. And this is also called 1 Faraday. So 1 Faraday is the charge carried by 1 mole of electron, and it is equal to 96500 coulomb per mole. Keep in mind that 1 Faraday deposits 1 equivalent of a substance. 1 Faraday deposits 1 equivalent of a substance. 1 equivalent of a substance. So 1 Faraday deposits 1 equivalent of a substance. Keep this in mind. Now let us see few examples. Suppose aluminum 3+ ion is there, and they are asking you how much charge in the form of coulomb, or you can say Faraday, is required to reduce aluminum 3+ to aluminum. You know that 3 moles of electron is required to reduce 1 mole of aluminum. So 3 Faraday gives 27 grams. So 1 Faraday will, so here 3 Faraday is required to give 27 gram aluminum. Suppose they ask you 1 Faraday will reduce how much? So 9 gram. That is also equal to equivalent weight in grams. So gram equivalent weight of aluminum is 9 gram. Equivalent weight of aluminum is simply, you can say, atomic weight by valency. Valency is 3. So that is 27 by 3, that is 9. So when equivalent weight is expressed in gram, it is called gram equivalent weight. Next question. How much copper is deposited How much copper is deposited on the cathode if a current of 3 ampere is passed through aqueous copper sulfate solution for 15 minutes. So let us solve this question. Solution. How much copper is deposited on the cathode if a current of 3 ampere is passed through aqueous copper? So copper sulfate aqueous, it will form copper 2 plus ion plus sulfate ion. Copper 2 ion will take up 2 moles of electron to form copper. This will go at cathode. That means 2 Faraday deposits 63.5 grams. So 1 Faraday will deposit 31.75 grams. So now they are giving current. Current is given 3 and time is 15 minutes. Minute has to be converted into second. So 60, 50, 900, 2700 coulomb. So this is the charge that is given. So if 1 Faraday can deposit itna gram, that means 96500 coulomb deposit 31.75 gram. So we can easily find how much 2700 coulomb will deposit. So 1 coulomb will deposit 31.75 upon 96500. So 2700 coulomb will deposit 31.75 upon 96500 into 27. If you solve this, you will get 0.889 grams. So this is the amount of copper deposited when 3 ampere of current is passed through copper sulfate solution for 15 minutes. Keep also in mind that, student, you can do this shortcut method also. W is equal to EIT by 96500. So keep in mind that equivalent weight of copper is atomic weight by 2. So atomic weight is 63.5 by 2. Current is 3. Time is 15 minutes, but minute has to be converted into second upon 96500. So 1 cancel, 2, 3. So it will be 63.5 into 9 into 15 upon 9650. If you solve this, you will get exactly this much. So this is also the way to solve this question. So this much gram of copper is deposited at the cathode when current of 3 ampere is passed through aqueous copper sulfate solution. Now let us look at Faraday's second law. Faraday's second law of electrolysis. So second law says that the amounts of different substances deposited or dissolved by the same quantity of electricity are proportional to their respective chemical equivalent weights. So it says that the amount of different substances deposited or dissolved by the same quantity of electricity are proportional to their respective chemical equivalent weight. So when different substances are taken in added in series, and W, you know that W is equal to EIT by 96500. So we can write W by E is equal to Q by 96500. This is nothing but number of equivalents. So W by E is equal to constant, as charge is same, So W is directly proportional to E. So we can write W copper by W zinc is equal to equivalent weight of copper by equivalent weight of zinc. So this way you can solve questions. So this means if the quantity of charge passed through electrolytic cells connected in series is same, the equivalence of substances deposited at various electrodes would be same. Like if suppose one Faraday is passed, suppose it is zinc electrode dipped in zinc sulfate, copper electrode dipped in copper sulfate, silver electrode dipped in silver nitrate, then if same quantity of charge is passed, that like one Faraday is passed, then it will deposit one equivalent of a substance. So one equivalent of zinc is 32.5 gram. So it will deposit 32.5 gram if one Faraday is passed. Copper 31.75 gram, silver 108 gram. So this way you can understand that if the quantity of charge passed through electrolytic cell connected in series is same, the equivalent of substance deposited at various electrode would be same. So when one Faraday is passed through zinc, copper, silver, all are connected in series, then the amount of zinc deposited will be 32.5, amount of copper deposited is 31.75, amount of silver deposited is almost 108 gram. So substances deposited according to their equivalent weight. Equivalent weight is equal to atomic weight by valency. So equivalent weight of copper is equal to atomic weight 63.5 upon valency is 2, so 31.75. Equivalent weight of zinc is 65 by 2 because it's also so plus 2 state, that is 32.5. Equivalent weight of silver is 108 by 1 because silver so mostly 1 plus state, so 108. So this was Faraday's law of electrolysis, student. I hope you understood. So let me discuss one question based on Faraday's second law. The question is, three electrolytic cells A, B, C containing solutions of zinc sulfate, silver nitrate, and copper sulfate respectively are connected in series. A steady current of 1.5 amperes was passed through them until 1.45 gram of silver deposited at the cathode of cell B. How long did the current flow? What mass of copper and zinc were deposited. So it looks a very big and intimidating question, student, but actually it is very easy. So it is based on Faraday's second law. It is based on Faraday's second law. So 3 electrolytic cell A, B, C containing zinc sulfate. That means it is zinc electrode dipped in zinc sulfate. B is silver electrode dipped in silver nitrate, and C is copper sulfate dipped in copper sulfate. They are connected in series. A steady current of 1.5 ampere is passed through them until 1.45 gram of silver deposited. So A, B, C. A is zinc sulfate. That means it is zinc electrode. This is silver dipped in silver nitrate. This is copper dipped in copper sulfate. Now, silver deposited is 1.545 gram. Current passed is 1.5 ampere. That means equal amount of current is passed. So we don't know for how much time the current is passed. So mass of copper we have to find out and zinc deposited, as well as how long did the current flow. So 108 grams silver requires how much current? 96500 coulomb. So 1 gram will require how much? 96500 upon 108. So 1.45 gram will require how much? 1.45 gram will require 96500 upon 108 into 1.45. You have to calculate. This will give you the coulomb. Now, you know that Q is equal to IT. So T is equal to Q by I. Q is equal to T is equal to Q by I. So Q, you have to put this one, and I is this. So 96500 into 1.45 upon 108 into 1.5. This will be in second. If you divide by 60, then this will be in minute. This will be in minute. So 96500 into 1.45 upon 108 into 1.5 into 60. If you divide by, then this will be in minutes. So let me just find out, calculate the time. Nine 500 into 1.45 divided by 108 divided by so it is 14.39 minutes. That is approximately, you can say 14.4 minutes. So the time for which this current passed was 14. Now they're asking the weight of copper. So weight of copper by weight of silver is equal to equivalent weight of copper by equivalent weight of silver. So weight of copper you can find out. So weight of copper is equal to weight of silver into equivalent weight of copper by equivalent weight of silver. So weight of silver is 108 and not 108. That is equivalent weight. 1.45 is given. 1.45 into equivalent weight of copper is 31.75. Silver is 108. So if you solve this, you will get the answer. 1.45 into 31.75 divided by 108. So it is coming 0.426 gram. So the amount of copper is 0.426 gram. Now, weight of zinc by weight of copper is equal to equivalent weight of zinc by equivalent weight of copper. So weight of zinc can easily be written weight of copper into equivalent weight of zinc by equivalent weight of copper. So that is weight of copper came 0.426 into weight of zinc. Equivalent weight of zinc is 32.5 upon 31.75. So into 32.5 divided by 31.75. So this will be 0.4363. This will be the amount of zinc deposited. So this way you can solve the question based on Faraday's law of electrolysis. Thanks for watching, student. Do like and subscribe my channel. I'm coming up with lots of videos. So this is Sandeep sir signing off.